Hi, hello everyone. How are you? I hope you all are fine with God's grace. By the way, I'm Bharta Bandhavi of grade 8 and I am from TSWREIS JC Isnapur. Today I'm here to discuss a concept in mathematics with you all, and I'm very excited that today me and you, both of us can learn something new, aren't we? Shall we learn? Here you go. See, last year I went to summer camp with my friend Shravya. There, a camp counselor visited our room and shown us a big wall. He said us to cover that wall fully with different color papers. We did that. Next day he came to check whether the work which is given by him is completed or not. He observed and he said, yes, everything is good. He appreciated both of us for our work. Then he observed that wall still closely and he noticed that some corner of wall is not covered with color papers. He asked us the reason. Why didn't you cover that corner of wall with color papers? Then we said that, sir, actually all these color papers are in the shape of rectangle, but that corner of wall is not in the shape of rectangle and color papers are not getting sufficient, so what could we do? Then again he asked us a question that how many color papers do you need to cover that corner? Then we were silent. But suppose imagine if a teacher makes a girl stand and asks her a question, if the girl don't know the answer for that question, what will she do? She'll just simply stand static, right? In the same way, I and my friend stood static silently. Then he immediately said, don't worry, you can tell that. But to tell that, you should find out the area of the wall. Hold on, area, what's that? I think these type of questions and doubts are raising in your blooming minds. Am I right? Just don't worry about that. Before jumping into area, let's brush up on some preliminary concepts like open figures and closed figures. Now see, this is an instrument which we use in embroidery. Now just imagine this is the starting point of this instrument. I am rotating. Am I reaching the same point? Yes, I am reaching the same point. So, if a figure has starting and ending point same, we say that figure as closed figure. To tell simply, we don't find any gap in between. And now tell me, do you notice any difference in the first case and now? Yes, in the first case it's closed figure and now it's open figure. But how can we differentiate that? Well, see, imagine this is the starting point of this instrument. If I start rotating from here, again I'll not reach the same point. So, if a figure doesn't have starting and ending point same, we say that figure as open figure. To tell simply, we find gap in between. Not only this instrument, bangle, photo frame, technicoid, these are some of the examples for closed figures. Now, could you give me some examples for open figures? Yes, jet coil, hypnotizing symbol, broken bangle, broken photo frame. These are some of the examples for open figures. As here, its starting and ending point are not same. And now see here, this is a closed figure. And now it has become an open figure. I hope you understood about this concept. Now it's time to discuss about area. Area is just nothing but the amount of space occupied by a closed figure. Observe the slide. We find a leaf on the slide which is green in color and the leaf is occupying some space. Here the green color is the shaded region of the leaf and it indicates the space occupied by the leaf. So the green color is the area of the leaf. If you observe, you also notice that the green color is also the shaded region and the interior region of the leaf. The interior region of any object is the area of that object. Now let's discuss about regular and irregular shapes. Regular shapes are just nothing but if a shape has all sides and all angles equal, we say that shape as regular shape. Equilateral triangle, square, regular pentagon, regular hexagon, these are some of the examples for regular shapes. Now tell me, do you notice any similarity between all these shapes? You are amazing! In all these shapes, all their sides and all their angles are equal. That's the reason why we say all these shapes as the examples for regular shapes. Now coming to irregular shapes are quite opposite to regular shapes. That means if a shape doesn't have all sides and all angles equal, we say that shape as irregular shape. As you can see many pictures on the slide. In all those pictures, all their sides and all their angles are not equal. So, there are some of the examples for irregular shapes. Now here there are many shapes. I'll pick each shape randomly. What you should tell is that you should tell whether the shape is regular or irregular. Now here it is. This is an equilateral triangle. Here all its sides are equal and all its angles are 60 degrees. So this is a regular shape. And now in the same way, here all its sides and all its angles are not equal. So this is an irregular shape. This is a pentagon. If a shape has 5 sides, we say it as pentagon. Here all its 5 sides are equal and all its angles are 108 degrees. So this is a regular shape. Here all its sides are not equal and all its angles are also not equal. So this is an irregular shape. Last but not least, I think you are much familiar with this figure. What's this? Yes, this is a square. Here all its 4 sides are equal and all its angles are 90 degrees. That means right angles. So this is a regular shape. I hope you got an clarity about regular and irregular shapes. Now tell me, I think we are missing something. We still didn't discuss the main title of the concept that we are going to learn today. Did we? Any guesses? Well, today we are going to learn about finding area of irregular shapes. As we already discussed, area is just nothing but the amount of space occupied by a closed figure, and if a shape doesn't have all sides and all angles equal, we say that shape as irregular shape. By this class, we will learn about the concept of area and how to find out the area of irregular shapes, what are the ways to find out the area of irregular shapes, and also applications of area and irregular shapes. Shall we proceed? Here you go. Now tell me, how can we find out the area of irregular shapes? There are 3 ways to find out the area of irregular shapes. We can find it by using graph paper, by using grid paper, and there is other method. We can find its area by dividing that irregular shape into some basic shapes. First, let's discuss about graph and grid papers. Observe the slide. This is a graph paper which you can see on the slide. Here we find many boxes. We call those boxes as squares. Here each square is a unit square. If its side is meters, then its area will be square meters. If its side is centimeters, then its area will be square centimeters. For large measures, we use hectare as the unit of area. 1 hectare is equal to 10,000 square meters. Not only hectares, square meters, square centimeters, we have many other units of area like square yards, square inches, square feet, square millimeters, etc. Mostly we listen this word hectare near construction of buildings and agricultural fields. And see, grid and graph papers are almost familiar with each other. But the only difference we can find is in graph paper we can find millimeter squares, but in grid paper we don't find that. Now let's find out the area of a leaf by using graph paper. This is a leaf, and now the primary and fundamental step in both grid and graph papers is to trace the outline of the given figure on the paper. Before it's a leaf, and now this is the outline of the leaf. We can find the area of any figure by using these methods by counting the squares which are occupied by the figure. That means if the figure occupies 1 square, take it as 1 full square, and if it occupies more than half square, consider it as 1 full square, and if it occupies half square, take 2 half squares as 1 full square. That means half plus half, 1. In the same way, half square plus half square, 1 full square, and if it occupies less than half square, don't consider it, just leave it. Now observe that leaf. How many full squares does it occupy? Yes, it occupies 47 full squares. So, the area of the leaf on graph paper is 47 square units. Here we didn't took its side as meters or centimeters. So simply we took its area in units. In the same way, now let's find out the area of a figure by using grid paper. See, this is a grid paper. And now here we can't find millimeter squares. The procedure we follow for grid and graph papers is also the same. Observe the slide. What do you find on the slide? Yes, it's a map. Is this Indian map or an African map? No. In which state are we living? We are living in the state of Telangana. It's Telangana map. Now let's find out the area of the Telangana map by using grid paper. As we already know, the primary and fundamental step is to trace the outline of the figure on grid paper. Before it said Telangana map, and now this is the outline map of Telangana. Now observe that outline map. How many fill squares does it occupy? It occupies 17 fill squares. So now let's count half squares which are occupied by Telangana map. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. The Telangana map occupies 12 half squares. But as we already discussed, if the figure occupies half square, we should take 2 half squares as one fill square. Now we have counted individual half squares. Now let's group 2 half squares together and let's count once again. 1, 2, 3, 4, 5 and 6. So the Telangana map occupies 6 fill squares. Now to get the total area of the Telangana map, what we should do? You are just amazing. To get the total area of the Telangana map, we should put 17 and 6 together. That means we should add them. And the sum of 17 and 6 will be 23. So the total area of the Telangana map on grid paper is 23 square units. Here also we didn't took its side as meters or centimeters. So simply we took its area in units. If we follow this method, then we'll get the total area of any figure by doing the sum of fill squares, half squares and more than half square. Now I want to share an instance with you that few days back I went to my grandmother's house on the occasion of Sankranti. Then after reaching the house, I went to our field with my parents. Then I asked them to tell the area of the field. Then they simply said, we don't know ma. So I thought, why can't we find the area of this field by using the first 2 methods? But this field is really a very big shape, and also since it has an irregular shape, it's not possible. Can we place the agricultural field on grid or graph paper? Can we trace the outline? No. So in this case, it's not possible. But can we use the third method? Let me try. That means as this field is in the shape of irregular, I will divide this irregular shape into some basic shapes, and by using the formulae, I'll calculate the area of the field. As we already read some basic formulas to calculate the area of some basic shapes in your earlier classes, like area of rectangle is length into breadth, and area of the triangle is half into base into height, and area of the square is side into side. Area of the trapezium is half h into a plus b. Here h is nothing but the height of the trapezium, and a and b are the parallel sides of trapezium. There are many shapes and also areas for them, but it's not possible in this case. So now let's try by using the third method. But before going into that, let's find out the area of some irregular shapes. See, observe this irregular shape. In how many shapes can we divide this? And always remember, there will be many ways to divide, but always choose the easiest way to divide so that you can solve the problem easily and quickly. We can divide this irregular shape into 3 basic shapes as triangle, rectangle and trapezium. First of all, let's calculate the area of the triangle. Area of the triangle is half into base into height. Here, the base of the triangle is 6 and the height of the triangle is 7. So, if we multiply half, 6 and 7, we'll get 21. So, the area of the triangle is 21 square meters. Here all its dimensions are in meters. If the side is meters, then the area will be square meters. In the same way, now let's calculate the area of the rectangle. Area of rectangle is length into breadth. Here the length of the rectangle is 8 meters and the breadth of the rectangle is 6 meters. So now if we multiply 8 and 6, we'll get 48. So the area of the rectangle is 48 square meters. In the same way, the area of the trapezium is half h into a plus b. Here height of the trapezium is 2 and value of a is 6, value of b is 9. If we simplify that, we'll get 15. So the area of the trapezium is 15 square meters. Till now, we have found the areas for each basic shape individually. Now, to get the total area of this irregular shape, what we should do? You are right. To get the total area of this irregular shape, we should put all the areas till now which we have calculated. That means area of the triangle plus area of rectangle plus area of trapezium. 21 plus 48 plus 15. And the sum of all these areas will be 84. So, the total area of this irregular shape is 84 square meters. In the same way, now let's calculate the area of the other irregular shape to understand the concept with a clarity. Now observe this irregular shape. In how many basic shapes can we divide this? We are dividing it into two basic shapes as square and rectangle. As we already know, the area of the square is side into side. Here, the side of the square is 2. So, if we multiply 2 and 2, we'll get 4. So, the area of the square is 4 square centimeters. Here, all its dimensions are in centimeters. If the side is centimeters, then the area will be square centimeters. In the same way, the area of the rectangle is length into breadth. Here, the length of the rectangle is 6 centimeters and the breadth of the rectangle is 3 centimeters. If we multiply 6 and 3, we'll get 18. So, the area of the rectangle is 18 square centimeters. Till now, we have found the areas individually. Now, to get the total area of this irregular shape, we should put the area of the square and area of the rectangle together. That means 4 plus 18. And the sum of 4 and 18 is 22. So, the total area of this irregular shape is 22 square centimeters. In the same way, now let's calculate the area of the shaded region of an irregular shape. See here, the total figure is square. And here we find two semicircles. If we put those two semicircles together, a circle is formed. And here we find a shaded region. So now we are going to find out the area of this shaded region. First of all, here the side of the square is 14 centimeters and the line segment which passes through the center of the circle is called as diameter. And now here the diameter of the circle is 14 centimeters and radius is half of the diameters. That means diameter by 2. Here the diameter of semicircle is 14. So if we divide 14 and 2, then we'll get 7. So the radius of the semicircle is 7 square meters. Now to get the shaded region, the area of the shaded region, we should subtract area of the square and 2 into area of the semicircles. That means area of the square is side into side. So we should subtract it from the area of the semicircles. Area of the semicircle is half pi r square. Here pi value is 22 by 7. So if we multiply 14 and 14, we'll get 196. So the area of the square is 196 square centimeters. And now if we simplify the area of the semicircle, then its area will be 154 square centimeters. Now to get the area of the shaded region, we should subtract area of the square and area of two semicircles. That means 196 minus 154. If we do that, then we'll get 42. So the area of the shaded region is 42 square centimeters. I hope you understood about this concept. Now let's find out the area of the field which is in the shape of irregular. See, this is the shape of the field which I saw near my grandma's house. Now observe that shape. In how many shapes can we divide that? We are dividing it into 5 basic shapes as 3 triangles and 2 trapeziums. First, let's find out the area of the triangle DEI. Area of the triangle is half into base into height. Here, the base of the triangle is 60 and the height of the triangle is 40. So now, if we multiply half, 60 and 40, we'll get 1200. So, the area of the triangle DEI is 1200 square meters. Here, all its dimensions are in meters. If the side is meters, then the area will be square meters. In the same way, the area of the trapezium is half h into a plus b. Here, the height of the trapezium is 70 and value of a is 50, value of b is 60. If we simplify that, then we'll get 3850. So, the area of the trapezium EFGI is 3850 square meters. In the same way, calculate the area of other 2 remaining triangles and trapezium. If you do that, you will get their areas as 1250, 2800 and 1600 square meters respectively. Now, to get the area of the total field, we should put all the areas till now which we have found. That means area of 3 triangles and 2 trapeziums. So, if we do that, we will get its area as 10,700. So, the area of the total field is 10,700 square meters. I hope you understood this concept. Not only these figures, we can calculate the area of any figure by using these methods. Now tell me, why we should learn about all these concepts? Is that important? First of all, mathematics is really a very great and an interesting subject. Without mathematics, we just can't imagine our life. What we do from dawn to dusk, everything is connected to mathematics directly or indirectly. And the concept of area plays a vital role in mathematics. Without area, there is no life to geometry and trigonometry. These concepts are used in many professions. Like for example, carpenters use the concept of irregular shapes in making wooden items like wooden chairs, wooden tables, wooden benches and etc. And architects study deeply about the concept of area while they're constructing the buildings. Without these concepts, all their constructions may collapse. And if you observe the slide, there you can see many irregular shapes. So they use these irregular shapes in their constructions to make their constructions to look so attractive. And artists use the concept of area while they paint. And they also use irregular shapes in their paintings to make their paintings to look so colorful. And now coming to weavers. Weavers may not be formally educated, but they have complex calculations on their fingertips. As you can see here, they may be illiterate, but they use all these concepts while they are weaving. And observe the slide. There you can see a cloth. In that cloth, all those patterns are irregular shapes. They use these irregular shapes while they weave to make the cloths to look so colorful and attractive. And tailors also use these concepts while they are stitching. And see, not only they, even we use these concepts in our day-to-day lives. For example, if we want to paint a wall, how much painting is needed? There we use the concept of area. And if we want to make the same wall to look so colorful and attractive, in that case, we can use some irregular shapes. And if we want to install a carpet in our balcony, then how much carpet is needed? There we can use some concept of area. And if we observe that carpet, we find many irregular shapes on that carpet. And not only these, we also find many irregular shapes on our daily wears like dresses, kurtis, saris and etc. And also, we use the concept of area in constructions of buildings, temples, churches, mosques, etc. If we observe some historical monuments like Golconda Fort, Taj Mahal, Charminar, there we can see many irregular shapes. So, what we see almost is about irregular shapes. So at least we should learn some basics about these concepts. Now I want to tell you a quote that what you learn today, apply it to tomorrow. That means daily we will be learning many new things, but don't forget it then and there itself. Just apply it to your daily life. That means just try to connect it to your daily life so that you can remember the concept for a longer time and you can understand it effectively. Till now, we have discussed about the concept of area. Area is just nothing but the amount of space occupied by a closed figure, and also grid and graph papers help us to find out the area of some smaller figures. That means some smaller irregular shapes. And there is other method called dividing. That means we can divide the irregular shape into some basic shapes, and by using their formulae, we can calculate the area of the given irregular shape. And we also discussed about the applications of area and irregular shapes. We also found the areas of many irregular shapes by using those three methods. And we also learned some preliminary concepts like open and closed figures, regular and irregular shapes. Now here is a worksheet for you. Observe this. Here we find many irregular shapes. So what you should do is, you should find the area of all these irregular shapes shaded region. I'll do one for you. See here, we find an irregular shape. Now we can find its area by counting the shaded squares. Observe this irregular shape. First one. Count with me. Count the shaded regions with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here it occupies 11 shaded squares. So this is the area of this irregular shape. So today we have learned many things. Just try to apply it in your daily life. And finally I thank TSWREIS channel, the government of Telangana and the whole team of TSWREIS for giving me this wonderful opportunity. I enjoyed a lot. I hope you did it too. So I'll meet you in the next class with some more new interesting and energetic concepts. And I thank all the viewers for spending your valuable time and watching this class. I'll meet you in the next session. Bye-bye. Thank you.